What is the quiz out of?
College algebra, the material after test, what?
The points out of.
Oh, the points. There's 40 points. But there's 30 required points, so all of my quizzes are basically unfair because I give you the quiz before you completely understood. Okay, so I give you so like, I understand you're still sorting, not all of you finished the homework yet, right? It's due tomorrow. So you need to finish the homework. Obviously, finishing the homework before the test is probably a good idea. Finishing the homework before the quiz is also a good idea, but I understand you have other things in your life to do besides math homework. I get it. But I do need, the reason I put the quiz so far ahead of the test, my quiz is essentially a pre-test, right? So now you've seen what is likely going to happen to you next Wednesday if you don't fix some things, right? You kind of get a sense of where you are with the grading here. So that's why I do the quiz a little bit ahead of time. But on the flip side of things, I do realize that I don't want to, penalize people for like not understanding everything completely. So I try to put about 25% bonus points on this quiz, right? So I gave you 40 points to earn, even though 30 points would get you 100%, right?
So like in the grade book online, would it go in out of 30?
Yeah. Yep. That is correct. Let's see here. All right, so let's look at the solution together. So, second, let me find my laser. All right, so let's talk about problem number 1. By and large, people got problem 1 right, and this makes me very happy because that means that you have achieved one of the basic goals for this class, which is to gain familiarity with what graphs look like. And these are some of the basic graphs that you'd like to know for calculus or other applications, things like that, like the square root graph. Come on. The square root, oh man, it's working earlier. The square root graph, the absolute value graph, the cube root graph, and the volcano graph, right? And so as you look at these different choices, it's pretty obvious that this is the volcano, this is well, it's like half of a parabola, right? So that's got to be the square root one. This one looks like a V, so it's got to be the absolute value one. And this one looks like a sideways cubic, so that's got to be the cube root one, right? And a lot of you got that right. Now, something like 120 people have taken this, give or take 110, I don't know, whatever. No one, absolutely no one, noticed that this is wrong. This, in fact, this graph that was given is none of the above. Because this is actually, if you take this formula and then subtract 4 from it, that would be what is actually given. So something got lost in translation. I don't think it confused anybody. If it did confuse you for some reason, you can come talk to me about it. But anyway, I'll try to do better. Yeah, I always tell us, do better. Actually, pretty much anybody who tells you to do better, I want to punch in the face. But anyway, I digress. So this problem was pretty easy in a sense because why? Because I gave you 4 different types of functions, right? How would you have done on this problem if I had given you 4 parabolas and 4 parabola equations? Could you have still done it? Some of you are saying, yeah. Others of you are like, don't do it, don't do it. Don't do it on the test. But I might. All right. How are you going to fare if I make 2 of these the same kind of graph and then you actually have to think through the transformation idea, right? So I might make this a little bit more tricky on the test, possibly. And I'll try not to make a mistake on the test, obviously. So anyway, sorry about that. Any questions about this one? I like this problem format. I can test a lot on this problem without using up much space on our test, and I'm really wanting to make the test short, so it helps me. It helps me cover a lot of material at the same time, not making you guys write too much. So it's good in that way. All right, anyway, going on here. Problem 2. We had a lot of problems with problem 2. So complete the square. We get x minus 4 squared minus 5. Once I've completed the square, I can look at this and I can read from this the vertex is at 4 comma minus 5. A lot of you have a minus 4 here, which is a mistake. So a lot of you, like 20%, have minus 4 there. Something like that. I don't know. Some of you are trying to use the formulas that we derived for the vertex. And that's not, I'm not saying you couldn't do that. You could do that, but you got to use the formulas carefully, right? And some of you have not. Finding the x-intercepts. You know, I put these numbers down here for my own reference, just in case one of you guys use numbers, I could identify it, yeah? I'm not saying you need to find those numbers, all right? That's not my point. If it was an engineering class, then yeah, you probably should find the decimal numbers. Engineers like decimal forms. They don't really so much care about these things, right? These are for math majors, mathematicians, college algebra books, stuff like that. Okay, so factoring, since it's a minus, we can factor, right? So a lot of you tricked yourself into thinking this one was prime. If this was prime, that would have been kind of a nasty question for me to ask, because I would have been asking you find the coordinates of the vertex and two things that don't exist, right? That would be a trick question. I'm not that tricky in here, usually. If I'm tricky, it's because I made a mistake writing the test. It's not probably a genuine, you know, move. I don't try to be tricky in here. Now, also, I've asked for the coordinates, right? So coordinates are what? X and Y. So these are pairs, right? A point is a pair of coordinates. So the coordinates for the vertex are 4 minus 5. The coordinates for the x-intercepts are this 4 plus or minus root 5 comma 0, right? I don't think I took off points if you just told me 4 plus or minus root 5, you know? However, if you just circled that you'd factored it and said that's the x-intercepts, I took probably something off. Because there is a distinction between factoring and zeros. I need you to at least tell me, well, the x-intercept is at x equals to 4 plus or minus root 5. Like I can give full credit there. It's not technically what was asked for. I asked for coordinates, which means you need the x and the y. In contrast, problem 3, any questions about this? So I'll tell you what I told the other two sections today, which is that everybody should be able to get this problem right on the test. There's nobody here who cannot do this problem, all right? If you need more help with how to do completing the square, we can take more time Monday to dive into completing the square again, go step by step. We can do 5 more basic examples together, all right? Whatever it takes. But you need to learn completing the square, and you need to learn how to identify the vertex off that. I mean, it's kind of an important little factoid for this test, is you need to be able to just read the vertex off the completed square form, right? Yes, you could use the formulas that I derived, but like you shouldn't need to, is my larger point. And you should also, you know, be able to factor when it's ugly, right? So these are two important algebra skills that if you haven't picked up yet, you need to like try to get those, you know, dialed in or whatever you want to say. I mean, you want to make sure that you are ready for test 2 knowing how to do this algebra right here. Because this algebra doesn't go away, right? It was on the first test. Now it's on the second test, right? It's also going to be in the final. Students who don't know how to do these algebra steps are students who really should not pass my class, honestly. Now, do I pass some students who don't know how to complete the square? I'm sure I do, right? I'm not that good a grader. Well, there's a faculty here who used to be here. He's passed away a couple of years ago now, but he used to say that doctors bury their mistakes. We just we graduate ours. So Yeah, so there is some truth to that. But if I was doing my job like I should, anybody who can't do this algebra right here, I should stop you and send you back to the start of this class again at the end of the semester, right? So you need to get this. It's something we can all get, right? It's totally no shame, no judgment if you haven't got it yet. It's not too late, right? It's not too late. You can still get it. And if you have bombed the first test, remember we do replace the final exam grade. I don't know where I'm walking to. What's wrong with me? Anyway, many things, but let's see here. So what I'm trying to say is, don't count yourself out. You can do these things. Take a second to regroup. If you got a bad score, look past it and just look at it as an opportunity to not get that score on the test, right? Just because you got 30% on the quiz doesn't mean you have to get 30% on the test, I may not be talking to anybody in this room, actually. So, actually, I think in here, I've got like about, how many? There are 6 100% are above in this room. So that is not true of other sections. I think you guys are my strongest section by quite a bit. All right. Anyway, so the next one here, we've got x squared minus 4 See, you got to commit to opening the door quietly. You open the door loudly, but then you shut it quietly. There's an asymmetry. You got to...
Michael said he's not feeling today, so he's not going to be here.
Oh, Michael? Michael... Do you like a roommate or something, or do you know him? If I gave you his, could you take it to him?
Yeah.
Cool. So we're going over the solution. And Mike, is that this kid right there? Him, right?
What's right there? I don't know his last name.
Do you know him? I mean, can you take this to him?
Yeah.
Okay. That's all I'm asking.
I don't know last name. I don't know.
Oh, that's fine. But if you, like, you know where he lives, you're gonna see him this weekend, whatever, right?
Yeah, I'm roommate.
Cool. We're going over the solution to the quiz. So we've now got to problem 3. And so again, problem 3, a lot of you got wrong in a lot of different ways, all right? So like a lot of people have listed like 3 numbers here. I don't know what to do with that. Like you've listed all the critical numbers here. I guess you're like, it's kind of like carpet bombing, right? You just like shoot everything that possibly is right and hope that I'm going to circle the correct one and ignore the other 2 or something. I don't know. I'm not sure what the logic is, but there is just one answer for each one of these. The x-intercept is at -2. The vertical asymptote is at -1. The hole in the graph is at 2. Right? So if you just wrote, -2, -1, and 2 here, I give you full credit, all right? But what I've written is better, right? Because the x-intercept is technically at -2, 0. Now, why is there an x-intercept at -2, 0? Let's look at the formula, right? X minus 2 corresponds to the x plus 2 factor. Notice that it's just in the numerator, right? So that's why we have an x-intercept, because that makes the numerator 0 and hence the fraction 0, which gives us -2, 0 in the graph. Now x equals to -1 corresponds to this x plus 1 factor, which is not balanced by any other x plus 1 factor on the numerator, right? So x plus 1, which is 0 when x equals -1, gives us division by 0. This means we have a vertical asymptote in the graph. The vertical asymptote we can't define by a point. It's actually a whole range of things, right? So it's x equals to minus 1 is its equation, to be fussy. Now, admittedly, the language I used in this problem really doesn't permit me to take off points for you not adhering to my format here, right? Because I didn't say, like, give me the coordinates or the equation or something like that. And maybe I don't want to. Okay, so anyway. I mean, my brother says that if a student tells you that the hole in the graph is at 2, and then you say, no, the hole in the graph is 2 comma 4/3, my brother says you're just a jerk. So I don't want to be a jerk. Like, I want to count 2 as correct here, but it would be good if you knew how to get the 4/3, right? We get the 4/3 by looking at the reduced function. So it's a hole in the graph because we've got x minus 2 and x minus 2 upstairs and downstairs, right? And as such, the reduced function is x plus 2 over x plus 1, which is when I cancel these guys out. And then I plug 2 in, I get 2 plus 2 over 2 plus 1, which is 4 over 3. And that's why the hole in the graph is at 2 comma 4/3. All right. So I did actually want to force the issue of making you find the 4/3. That is true. That was on my list of things to do, and I failed to do it with my wording. So that's something I would want to fix on the test, all right? So we can read into that what you want. So, because I didn't test hole in the graph in the next page, right? On the graph, in problem 5, there was no hole in the graph, so I didn't really test your ability to find where the hole is there. I was trying to do that in problem 3, and I just didn't. Any questions about problem 3 before I really go on? Okay. So here, this is easier than you think it is if you got it wrong. So 3f of 2 is 3 times f of 2. F of 2 is right there. F of 2 is 2. 3 times 2 is 6. That's all there is to it. Fg of minus 1, that's the product of f and g. That's f of minus 1 times f of g of minus 1. Now f of minus 1 right here is 0, right? G of minus 1, plug it in. 3 times minus 1 squared minus 3, which is 3 minus 3, which is, so it's 0 times 0. I mean, it's really, really 0. All right, so a lot of different ways you could have seen that was 0. Well, 2 different ways. The third one is, I think, by far the most challenging conceptually, which is the composite. So here, f composed with g of 1. By definition, that's f of g of 1. And g of 1 here, I plug in the formula. I get 3 minus 3, so I get f of 0. What is f of 0? I go back to my graph. F of 0, right here, f of 0 is 1. So we're looking for a 6, a 0, and a 1 here. All right. So some of you are still not quite where you need to be conceptually in terms of reading values off a graph, right? If you're not confident about that yet, you need to get confident about it because it's something that's going to keep coming back up, right? Because one of the goals for this course is for you to be able to read data off graphs. And so, like, this is one of the aims of this course, is for you to be able to read off this graph things like f of minus 1 is 0, f of 0 is 1, f of 2 is 2. You know, that's something we want to achieve in here. It's not something I focus a lot on. I mean, I would say that you probably should have picked that up in the previous course, but if you didn't yet, well, then this here. Now here, so let me give you the backstory on this one. I don't know which section I was grading. It wasn't this section, or some other section. I was grading it, and I looked at the first. I grade problem by problem, guys. Like, I grade a section. I grade one problem for the whole section typically. Sometimes I grade a whole page at once. And so I was grading problem number 5, and I looked at the first page. I looked at the first solution, and it was just really, really wrong. And I looked at the second one. It's really, really wrong. Like, no, there's no vertical asymptotes to be seen. Just I can't even tell you what I saw. And you look at another one, even more wrong. And about the 10th one of these I've seen, you know, it's just wrong after wrong after wrong after wrong. I was like, ah! And then finally, after about 15 wrong solutions, I come to this person, and it had the vertical asymptotes where they're supposed to be. The horizontal asymptote was at -2, It was positive where it was supposed to be positive. It bounced. Everything was where it was supposed to be. It was beautiful. And I thought, +2. +2. So I gave 2 bonus points to people who really did a nice job on this one because of that. Now, for me, that was an emotional journey of grading. If I hadn't taken that journey with that other section that did badly, some of you would not have got the 2 bonus points that you did on this, right? That doesn't always happen. So you have to hope for a pocket of really bad students who depresses me, and then like an awakening, like from the ashes, You guys ever seen Voltron? So the original Voltron, they used to have this awesome space castle that would like come up from the rubble of an old castle, like a really, really cool castle out of the ground. So that was that solution to me. It was like the Voltron castle. It's wonderful. Sorry, I was talking about Voltron in the other section. There's really no good way to make a segue for you guys since you were not there. But okay, so anyway, digressions aside, I did give some bonus points here if you really did a nice job. Okay. Now, okay, so let's just go through it. Looking at the formula, -2 is in the numerator. -2 makes the numerator 0, right? So that x plus 2 means that -2 is a x-intercept. In fact, since it's squared, it's going to be a bounce. So you notice I put the critical numbers, -6, -2, and 4 right here. And so I intentionally left you a little space above this so you could draw the number line here if you wanted to. -6 and -6 and 4 make the denominator 0. That means that those are vertical asymptotes, right? I also decided not to test hole in the graph at the same time I was testing everything else, because if I've got to test vertical asymptote, zeros, the sign chart, and hole in the graph all at once, it gets to be a bit much, both for you guys and for my grading. So I separated off the hole in the graph to the other problem. That was on purpose, So anyway, I hope that made it easier for you. So vertical asymptotes, it's at 4 and -6. And then I just got to make my sign chart. See, it's negative, it's positive, it's positive, it's negative. And then at that point, I'm like, oh, wait a minute. I need to figure something else out. What about the horizontal asymptote? Well, check it out. This is degree 2. That's degree 2. That means the orders of the numerator and the denominator are equal. So we can go back and use, either we can do long division, right, and get that we got a -2 from the long division. Some of you did that, I think. Or we can just use the leading zeros theorem, which is if you have the same order above and below. If you look at the ratio of the leading coefficients here, -2 and 1, that gives you the horizontal asymptote, which is -2. And then after that, you graph. So I said my graph does not include attention to detail about the y-intercept. You could add that to be more precise. I don't think anybody did that, and that's okay. I didn't ask about it though, did I? I could ask about that, right? I could ask where's the y-intercept. In some sense, that would have been helpful to some of you, because there are some people who graphed it somehow like this, if you watch me. And then they came down through here like that. Right? So if I had told you to find the y-intercept and you would have found out the y-intercept is positive, then you would have known that what you did by graphing down like that was wrong, right? So, if the graphing problem is worth a lot of points on the test, right, and you have time, it's worth your time to plug in a point or two to check yourself, right? How would you check yourself? It's really simple. All you have to do is find a number over here like -7 or -8 and just plug it in here and see what you get, right? Or try plugging 0 in. What do you get? 0 gives me -2 times 4, which is -8. -8 divided by -24. So apparently I get -8 over -24, which is 1/3. Yeah. So this point here, if I did it right, it should actually be at 1/3. So it should be more kind of like down here-ish, truth be told. All right. My point to you is, if you have time, it's worth your time to spend a minute or two plugging some points into the graph problem to make sure that you're right. So if you made some silly mistake, you don't bleed off 20 points of your test or something for it, you know? So just a thought. Problem 6. Okay, so here I give you a hint, which is to evaluate. What does evaluate mean? Plug in, right? So plug in 1, plug in 2, see what happens. What happens? Plug in 1, we get 1 minus 6 plus 11 minus 6, which is otherwise known as 12 minus 12, which is 0. The other one, I plug in 2, I get 8. 6 times 4 is 24. 11 times 2, you know, so I get, basically here I've got a minus 24, a minus 6, that's a minus 30. 8 plus 22 is 30. I got basically a 30 minus 30 altogether, of course, which is 0. What does this tell me? This tells me by the factor theorem that there's a factor of x minus 1 and there's a factor of x minus 2. If you have two factors, you can multiply them together and that will still be a factor, right? So we've used this trick on a number of problems. And so when I multiply them, I get x squared minus 3x plus 2. I divide that into here, and that gives me x. So when I multiply x, I get x cubed minus 3x squared, 2x. I subtract these. 6 minus a minus 3, minus 6 minus a minus 3 is minus 6 plus 3, which is minus 3. 11 minus 2 is 9, minus 6 comes down. Then to get minus 3x squared, I put a minus 3 up here. Multiply minus 3 by that. I get minus 3x squared. Minus 3 times 3 is plus 9. Minus 3 times 2 is minus 6. Remainder 0. Woohoo! Remainder 0 means it actually factored, right? If we didn't get remainder 0 here, that means we've made a mistake somewhere, right? Either in the long division or in the evaluation. Fortunately, we didn't make a mistake either place. So that gives me that x minus 3 times x squared minus 3x plus 2 is equal to the cubic, right? But where did this come from? This came from multiplying out x minus 1 and x minus 2, right? So I have this complete factoring of f of x, just like that. Now some of you have been cheating on me. I've seen the synthetic division. You've been going outside the sacred bonds of this class and doing math with another. I can see it in your synthetic division. I didn't teach you that behavior.
The homework did.
The homework did? Ah, the homework. What will I do about the homework? I know. I have a solution for next semester. I can't fix it for this one. But well, in my defense, I did say, and I made a big point about this, I think, everywhere it says synthetic division, cross that out and write long division in its place, right? You're like, well, that's lovely, but when I hit the video, which I rely on to do the homework, the video does synthetic division, therefore I do synthetic division, because whatever the video does, I do, right? Because this is the joy of the MyLab homework, is that you can, just like so many monkeys and so many typewriters, do the same things that the video shows you to. The question is, are you learning from that? I wonder. But anyway, doing homework is better than not doing homework. That much is still true. Nah. That sounds like the words of someone not doing their homework. You do your homework? Last minute. Are you an engineer? What's that? That is a hilarious response. I like that. I say, are you an engineer? You're like, what's that? You don't know what an engineer is? That's beautiful. Like that's well done, well played. Man, that's amazing. Did I tell you about the kid I had in algebra before? I made a passing comment about Thanos, and he claimed to not know who Thanos was. Yeah.
Is he serious?
That's like that kind of level of a comment. It's just it strains credibility. Like how, there are people who drive trains.
People that drive it.
Engineers, they're the people in the front of the train, the ones that,
You don't need to do that to a train though. You just put.
oh, well, yeah, it's got like levers and stuff, my bad. But yeah. So,
That's an engineer.
no, I was talking about like the third floor of this building, you know, the engineers. You're going to make me explain this, aren't you?
I'm being 100% honest. My major is zoological biology.
Zoo is what?
Zoo and wildlife biology.
Zoo and wildlife biology? You're a zoologist?
Well, just about, you know.
Just about?
Tackling bears, you know.
Tackling bears. I guess that goes better on the East Coast, but we did used to have a double major in math who was double major in zoology. Her name.
I want to major in math, but it's too hard.
No, math's easy. It's just one step at a time. There's hardly any labs, no papers, no memorization practically, compared to other majors. Like very little memorization.
I was good at math, but it's like I came back, it's like
Although I will say, if you're a math major, the one downside is anytime you tell like general people like your major's math, the response is universally pretty much they shudder in disgust. Like they're unapologetic. Like so, like I was undergraduate in math and physics. They'd be like, "What's your major?" I'd be like, "Math," and they go, and physics, and then they'd be like, "Oh, why?" It's like, and it wasn't like that's not like the outlier. That is the dominant mode of conversation about your major when you're a math or physics major. It's like everyone's just like horrified. Yeah, but we love it. So, oh well. Anyway, I digress. So this one here. So I asked if you're an engineer because engineers that I teach are, by and large, they view procrastination as a virtue, like one of the chief virtues of an engineer. Like, yeah, if you can do your homework on time and get it done weeks ahead with well planning and time management and stuff, sure, that's what they teach you in the engineering introduction class, all that stuff, right? But that's not what gets you respect on the street. What gets you respect on the street of engineering is if you can go to your friends and go, yeah, I started the homework for this until like last night. I got like 80, but I only spent 2 hours on it. And I think I just made a 70 on the test, but you know, I just spent one night studying. And they'd be like, whoa, that's like really good procrastination. And that's what I've seen anyway, a lot of that. They're very proud of putting things off. Although I did have friends like that in college. Anyway, I had a friend who ignored this class for like 3 weeks, and then I just talked to him about it in the library for 3 hours, and he made like a 70 on the test. He was very proud. 70%. I mean, 70% is not bad for a technical class. It's like 300 level. You've pretty much ignored it for like a month. You come in, you talk to your friend for 3 hours, you make a passing grade on a test.
That's good.
That's not bad, right? Yeah. And then he forgot all of it again by the next test. I had to explain to him again and again and again and again.
It might work with me though.
It does get annoying at some point, but okay, anyway. Yeah, back to this. So we talked about the complex theorem, the complex zeros theorem. Anytime we have alpha plus I beta, remember we got x minus alpha squared plus beta squared for the factor. So putting that into practice here for alpha equal to 1, beta equal to 2, I've got x minus 1 squared plus 4. That's my prime factor corresponding to that complex zero. And then I multiply it out, I get this. From 5, I get x minus 5 as a factor. So we're looking for a cubic, which is third order, right? So if you've got a first order and a second order, that's all you got. You got no room for anything else because by the time you got a quadratic times a linear, you're already to third power, so we're done. Except for the wiggle room we have in the front for our constant a. That a is fixed by the fact that we're given f of 0 is 50. So I plug in f of 0 is 50. That gave me a times minus 5 times 5. I divide both sides by minus 25. I get a equals to minus 2. And then I multiplied this out. All right. And then, why am I multiplying it out? what's the difference between problem 8 and problem 7? It would be nice if I had like bolded it or something, right? So standard form. So if I put something in bold, maybe you should look at it, you know. So I tried standard form here. And in here, no standard form, right? And yet still I have people multiplying this out. But anyway, I did not ask you to multiply these out. So multiplying it out gives me this, and then I multiply the 2 through, and there you go, there's your standard form. As a check, we should have a plus 50 over here. Now some of you tried to do some kind of like, you made up a new theorem for yourself. You're just like out of convenience. You're like, my answer is going to be this. I'm not going to write the a over here. I'm just going to write like x minus 5 times x squared minus 2x plus 5. And then I'm just going to add. I'll just add 50 over here. That's got to be it. This is not how it works. You can't just like add a number to the end of it when they're multiplied like that because of the way the algebra works out. Because when you multiply these out, it ends up giving you a minus 25. So if you just add 50, you end up with a constant not of 50, but of 25. And even so, that 2 has to multiply all of this stuff in order to make it work like it does. You have to do it the way I did it, unfortunately. But not unfortunately, because there is still time to figure out what you did wrong before the test, right? Listen, problem 8 went really well for most people. Like almost everybody in here, except like, there are people who left it blank. I understand, you know, it gets overwhelming at some point. When you don't understand problems, it starts to like, you start to doubt yourself, and that doubt grows and kind of snowballs for people, right? And so assuming you put an answer down here, almost everybody had x plus 6, x plus 2, x minus 4, right? And a lot of people had the x plus 2 squared. You got the bounce thing, right? But a lot of people like to bounce too much, and they like bounced this one and that one too. But the thing is, at minus 4 and at, excuse me, I can't read. At minus 6 over here, and at 4, there's no bounce. It's a crossing, right? And you're looking for least degree, so you don't want a cube there either, right? So we needed the x plus 6 and the x minus 4 over there. A in the front we don't know yet, but we'll find it from f of 0 equals to minus 48, so we do that. That leaves us with minus 48 divided by minus 96, which is giving us a half, which then, there you go, that's the answer. So I think if I ask one like this on the test, I think everybody can get this right. A lot of you are still working out your demons, so to speak, when it comes to figuring out the constant in the front, right? This problem of finding the constant in the front from looking at how it works at a specific data point and solving for A has appeared in how many problems now? It's appeared in a bunch of problems, right? It happened in this problem, it happened in this problem. I think it's happened in a problem in the previous page. I could be wrong. Well, anyway, it happened at least twice here. Did it happen before? Maybe it's just twice. I guess just the twice. All right. Any questions about that? Are we good on problem 8? Okay. I will post this PDF here in a little bit. All right. So problem 9. The question is, does this fifth order 3x to the fifth plus 11x cubed plus 2x squared minus 10, does it have a factor of x cubed plus 2? And then I gave you a hint. I said calculate f of x over g of x by long division of polynomials and answer the question. What question am I talking about? This question right here, right? So I did the long division. X cubed plus 2 goes into this fifth order, first of all with 3x squared. Multiplying 3x squared by that gives me this 3x to the fifth plus 6x squared. Then I subtract. I bring down 11x cubed. 2 minus 6 is minus 4. Minus 10 comes down. How do I get 11x cubed from a multiple of that? Plus 11. That brings down 11x cubed and the 22. I subtract. The 11's 11x cubed terms cancel. Minus 4 comes down. Minus 10 minus 22 is minus 32. And you're done. Because this has degree 2, your divisor has degree 3. Once your remainder has smaller degree than your divisor, you're done. That's when long division stops. And since the remainder is non-zero, that means it does not factor. All right? So a lot of people, some people had the correct long division, but they didn't answer the question. I took off a point. All right? Some people had the right answer to the question, but their long division was wrong. Other people had the right answer to the question. Their long division was really wrong. So I usually took off 2 points for the long division being wrong or really wrong. Anyway, as you know, my grading on the quiz is not terribly nuanced. I don't have like a lot of points to work with. My grading on the test is a little bit more nuanced. But anyway, so what this means is that f of x over g of x is 3x squared plus 11 minus 4x squared plus 32 over x cubed plus 2. And we could look at it that way, right? Or you can multiply this by the denominator and get f of x is 3x squared plus 1 plus 11 times x cubed plus 2 minus this other term. So I don't think I've told you guys this before, but you could look at this in some sense as like the closest thing you can do to factoring for this problem. Right? Like you can't factor out x cubed plus 2 from f of x, but you can do this much, and then you have this lower order piece over here. So this is as close as you can come to factoring x cubed plus 2 out of f of x is the way I think about it. But anyway, and then some of you were doing like some kind of synthetic division here. I have no idea what that means. Synthetic division only works with linear factors. Synthetic division can't touch this problem. It's x cubed. You only can divide by x minus 2 or a complex factor. To use synthetic division here, you would have to factor x cubed minus 2, x cubed plus 2. I mean, we could do that. Do you want to see how to factor x cubed plus 2? Let's do it. So how would we factor x cubed plus 2? Do you guys remember the formula? A cubed plus b cubed is what? A plus b, I think it is. A squared, I think it's minus ab plus b squared, if I remember right. That should be on your formula sheet from test 1, yeah? So if we think about that, we can factor this, because what we could do is rewrite this as x cubed plus the cube root of 2 cubed. And so you can think of this as, a equals to x, b equals to the cube root of 2. So we've got x plus cube root of 2, x squared minus the cube root of 2, x plus the cube root of 2 quantity squared. And so there you go. That's how you'd factor it. So if you're going to use synthetic division, the next thing you would do would be to try to do synthetic division with this piece, which means that you'd have boxes of cube roots of 2 to work with. And then if you were really a glutton for punishment, you could take this thing and find the complex roots of that and divide by that. And so after three synthetic divisions, one of which is cluttered with cube roots, and the other ones which is cluttered with cube roots and complex numbers, you'd finally be able to figure out that no, you can't factor out the cube root of 2, the cube root of x plus 2. Or you could do long division like we did. I recommend the long division. All right. So I think I've given everybody the quiz, right? Yeah.
Would I be able to take Emma's tutor?
Oh, sure. What? Who?
Emma Brock.
Absolutely. Anybody else know anybody else who's missing? Anybody happen to know Nick?
I know him, but there's not a good chance I'm going to see him for now.
You'll see Nick when?
He's on my call.
Oh, you'll see. So you